Okay, so let's begin with geology. Anybody know what that is? Where that is? If you've never been out west, you need to sometime in your life go out west and see a lot of the geological features of the earth that we'll be talking about today. That is Bryce Canyon, and it is in Utah. How many of you have ever been to Bryce Canyon? You didn't recognize it. Okay, so we're going to be talking about the geological features of the earth, and again we have two models or paradigms, the creationist paradigm and the evolutionary paradigm. Now, as far as the creationist paradigm, what view of geology goes with the creationist paradigm? We have two opposing views, uniformitarianism and catastrophism. So part of the creation paradigm is, of course, we're taking the entire book of Genesis. So what does that mean? That means we believe that the Genesis flood was an actual event and it was global in scale. Okay? So we're going to be talking about the flood in this section quite a bit. So let's begin with geology. What is geology? Of course, it's a discipline of science. Basically, we can divide science into the biological sciences, the physical sciences, and then the earth and space science. So geology is basically earth science. It's the study of the earth, its features, the materials of which it is made. So of course that would be rocks and minerals, its structures, and the processes acting upon them. That is a creationist view of geology. Geology is the science that studies the earth, its features, the structures that make it up, the materials of which those structures are made, that would be your rocks and your minerals, and of course the processes that are at work on the earth today. That is a proper study of geology. That's going to be the study of geology that fits our paradigm, the creationist paradigm, which when we're talking about geology, it's going to be catastrophism. All right? However, this science was the first science to be influenced, changed, altered, whatever, by evolutionary thinking, by the idea that the earth cannot be only 6,000 years old. We don't have creation. There was no flood. So this science was affected first. And this science is pretty much founded on uniformitarianism and old earth chronology. Okay? It predates evolutionary biology. After all, Charles Darwin, on his survey trip on the HMS Beagle that it was a worldwide, sailed around the tip of Africa, around South America, was not just a trip to the Galapagos Islands. It was a survey trip that lasted 5 years, and he brought with him a book called Principles of Geology, written by a man named Sir Charles Lyell, who was an evolutionary geologist, old earth uniformity. So here is a modern definition of geology. Notice the difference in paradigm. Okay, geology is the science that deals with the dynamics and physical what? History of the earth, the rocks of which it is composed, and the physical, chemical, and even biological changes that the earth has, what tense is that? Past tense, undergone or is undergoing. So you should put those definitions side by side in your notes and underline a few things about it so you can see the difference in paradigm. The previous definition, I deleted the idea of history and origins out of my definition of geology because that is historical science. It is not operational science. And keep in mind that of all the things science has done for us, very little of that has been accomplished by evolutionary biology or evolutionary geology. Operational science is the type of science that gives us advancements in technology and helps the world be a better place to live in. So this is a evolutionary view of geology. That evolutionary view of geology is called uniformitarianism. Uniformitarianism explains how the earth got here without God, so without creation, and without the flood. How did the earth get here? And how was the earth changed without the flood? So geology then is the science that deals with the dynamics and physical history of the earth. So it's a historical science. The rocks of which it is composed, and the physical, chemical, and even biological changes that the earth has gone. What tense? Past. One of the problems with historical science is that it happened in the past. So it's not directly subject to observation or experimentation. So we have three foundational principles of geology. Keep in mind, geology today is completely evolutionary. The first principle is called plate tectonics. We're going to talk about this. We're going to talk about all three of these. The next one is the geological cycles. Can anybody give me an example of a geological cycle? Yes? The water cycle. There's the rock cycle, the nitrogen cycle, and so forth. And then there's the foundational principle that governs geology today, uniformitarianism. All right, which of those principles are valid? Well, I think plate tectonics is. What is plate tectonics? This is the idea of, this is a model explaining the features of the Earth's crust, explaining movements of the Earth's crust, explaining volcanoes and earthquakes and so forth. Plate tectonics. Okay, the crust, which we can call the lithosphere. Lithos refers to stone. The lithosphere, which would be the bedrock that forms the Earth's crust. I'm not talking about the soil. We're talking about the bedrock that forms the Earth's crust. That's the lithosphere. Is a collection of rigid plates that move sideways above a less rigid layer called the asthenosphere. Plate tectonics has the idea that the crust is made up of a series of movable plates that are kind of floating above another layer, the asthenosphere. The asthenosphere is also rock, but it is fluid because the enormous amounts of pressure coming up from the core, the mantle and the core of the Earth. Here's a diagram of plate tectonics. Plate tectonics is a useful model. Okay, this is a principle of geology that we can see evidence of and that we can use to predict phenomena. Okay, so for plate tectonics, you can see here's the lithosphere. That's the bedrock that makes up the crust. Then we have the asthenosphere, a fluid layer of rock. It's hard to imagine rock being fluid. Of course, you've probably seen pictures of lava and so forth, which is very fluid, but rock inside the Earth is fluid due to high temperatures and pressures. And we can see different movements. You see this word here, subducted plate. That's one of the ways that plate tectonics move. They actually kind of slide over the other, one over the other, so that's called subduction, when one of the plates slides below the other. And of course, that can account for movement of the Earth's crust. Here's the plates that the Earth has been divided into. You can see a lot of them correspond to the continents. So plate tectonics, catastrophic plate tectonics, is a good way to explain how the continent, the Earth probably was a single continent, how that broke up into the continents that we have today. Of course, we're talking catastrophic plate tectonics, not uniformitarian plate tectonics. All right, and this, how many have ever heard of the Ring of Fire in the Pacific? okay, where we have a lot of volcanic activity and so forth. This is along one of the boundaries between the Pacific plate and one or another of these other plates. So plate tectonics is a legitimate principle of geology. Okay, is it a good theory? Is it a good model? I think that it is, because it's going to predict volcanoes, predict earthquakes. It has use as an operational science. It is still a model or a theory, because obviously we cannot, go to outer space and look through the earth with some type of X-ray vision and see the plates. But this seems to be a very good explanation for the movements of the Earth's crust, a good explanation and a good way to predict some of your volcanic activity and some of your earthquakes. Okay, so this is a good model. Geological cycles. Does the Earth recycle its raw materials? Does it? Yes. Materials on the Earth are continually being recycled, reused, and renewed. How did that happen? Set up by God. You should be familiar with the hydrologic cycle, dealing with evaporation, precipitation, runoff, and so forth. And even the rock cycle. Rocks are recycled as well. So we have plate tectonics as a valid theory or model in geology. We also know that we have geologic cycles. The problem comes with uniformitarianism. What is uniformitarianism? It's a presupposition that belongs to the evolutionary paradigm. What is a paradigm? It's a assumption. It's a basic assumption from which scientists reason. It's the basic assumption through which scientists interpret evidence. That's a paradigm. Okay, if you don't have it down, put it down again. A paradigm is the basic assumption that scientists use to reason from, that scientists use to interpret their data. So uniformitarianism is a presupposition of the evolutionary paradigm. Basically, we're going to deny creation. We're going to deny the fact that the Earth is less than 10,000 years old. We're going to deny biblical history. And we're going to try to explain the features of the Earth using only natural processes. Okay, so this is part of the evolutionary paradigm. It is a presupposition coming directly from the evolutionary paradigm. Here's what uniformitarianism is. As a matter of fact, even secular books will sometimes refer to it as a doctrine. Interesting, isn't it? It is a doctrine or a belief. It's the belief that the natural processes, natural laws, have always occurred at the same rate to shape geological features. So we're having the same processes acting at essentially the same rates. Here's a couple ways to summarize this view. Of course, uniformitarianism is the main pillar that supports evolutionary geology. And there are two key ideas. That sounds like a quiz question. In fact, I can guarantee it is a quiz question. Two key ideas of uniformitarianism. Look at this old picture. Anybody see the horse and buggy? This is an old picture. And then all the layers of strata below it. The two key ideas, same processes that acted in the past, and then these same processes are acting at the same rates. Same processes, same rates. Uniformitarianism. Okay, so uniformitarianism, here it is again. Uniformitarianism is the belief that natural laws and processes have always occurred at the same rate to shape geological features. It is the foundational principle of modern geology, which of course is the same as saying evolutionary geology. There's the two key ideas. Same processes acting at the same rate. Same processes, same rate. That's kind of the idea of uniformitarianism in a nutshell. Let's talk about this. Uniformitarianism versus uniformity. The principle of uniformity and uniformitarianism are not the same thing. Okay, they are not. We're not going to deny uniformity. Uniformity is a principle of science. Without uniformity, in other words, laws that govern how the earth runs, laws that govern biology, laws that govern physics, could we even study science if we didn't have uniformity? No, but we're saying that uniformity was established by God, and we're saying that uniformity can be interrupted by God at any time. So the problem with uniformitarianism is that it denies supernatural. It denies that catastrophic events have happened in the past, and it certainly denies that God interrupts processes. So the principle of uniformity is a principle of science. It's like the law of conservation. There are laws that govern biology. There are laws that govern genetics. There are certainly laws that govern physics, laws that govern chemistry, and laws that govern geology. So we're not going to deny uniformity. What we do say is that God established uniformity, and God is free to interrupt it anytime he likes. And as a matter of fact, he interrupted it quite significantly in Genesis chapter 7. So do you understand that? Because many times if you try to argue with someone who is evolutionary, they're going to throw some of these things in your face and say, well, of course the principle of uniformity is true. We can see the principle of uniformity. I agree. Uniformity is a principle of science, but do you see how they kind of just take it and use it in a different way? Yes, the principle of uniformity is true, and certainly true in geology, and certainly true in physics. But as a creationist and as a Christian, I understand that uniformity was established by God, and I understand that God can interrupt it anytime he so chooses. Do you understand that? That's important. The difference then would be that uniformitarianism is going to apply it to the past, and it's going to deny God. It's going to completely eliminate supernatural. And of course, we'd have a hard time explaining a 6,000-year history of the earth without creation and without God. So that's kind of the crux of this whole argument, is we are denying God. And we're denying the fact that he set up the earth and all of its processes in the case of geology, and we're denying that he can interrupt it when he chooses. I don't know about you, but I think that God established the principles of uniformity. He set up the earth to run, and run very well, and he can and has in the past interrupted anything that he so chooses. Okay, so do you understand that uniformity is not the same thing as uniformitarianism? We're not going to deny the principle of uniformity. It's a principle of science. Without it, we couldn't study science. Can you imagine trying to study physics? Well, you probably wouldn't want to study physics anyways, but can you imagine trying to study physics if the laws aren't constant, or if the rates aren't constant? We couldn't do much at all in operational science. Okay, so uniformitarianism attempts to use present processes. I should insert the word only. Present processes only to explain the Earth's present features. There's a couple things underneath this that kind of summarize the principle of uniformity. I put them in quotes because they are from evolutionary sources. Natural processes over geologic time. That's one way that we can summarize the principle of uniformitarianism as applied to geology. Okay, this is as applied to geology. So natural processes over geologic time. That's how we explain the features of the earth. Natural processes over geologic time. Again, no allowance for God, no supernatural intervention. And then the bottom quote is famous. The present is the key to the past. Who said that? Well, there's a little bit of discrepancy, and we're not quite sure who said that. A lot of sources say Sir Charles Lyell said that. I don't know, but it is the famous quote to summarize uniformitarianism. The present is the key to the past. All right, so what is uniformitarianism? It's a principle of geology that is going to explain the geological features on the earth by long processes. Geologic time, right here. Geologic time is code for what? Millions and millions, in fact, billions of years. And it would take millions and millions of years for these slow processes to work. So the goal here is for me to show you that they don't work, and that the evidence doesn't support them, and that there's nothing wrong with, I'm going to use the word invoking God in geology. We believe as creationists and as Christians that God created the earth, and God set up all the geological processes. And then in Genesis chapter 7, he completely disrupted everything with the universal flood. All right, so important proponents. James Hutton, 1726 to 1797, and Sir Charles Lyell. You can see he lived well into the 1800s. A lot of what we will be talking about, a lot of these foundational principles of geology occurred slightly before and at the same time as Charles Darwin promoting natural selection as a mechanism of gradualism. James Hutton. James Hutton is credited as being the originator. He's credited as being the originator of uniformitarianism. Okay, and he was from Scotland, so was Sir Charles Lyell. A lot of geological research and study began in Scotland. There's a lot of geological features there. Then Sir Charles Lyell, he is pretty much in the same boat, let's say, in the same respect as Charles Darwin. So with biological evolution, we have Charles Darwin. He gave the mechanism of natural selection. Very parallel. That's a better word. They're not in a boat somewhere. Okay, but very parallel. What Charles Darwin did for biology and biological evolution, evolutionary biology, evolutionary biology is a better way to put that as well. Sir Charles Lyell did the same thing for evolutionary geology. So he's very important. He popularized it, just like Darwin popularized gradualism. So Sir Charles Lyell. James Hutton, very foundational. He's credited again as being the originator of the ideas. Charles Lyell, however, was a much better writer. He wrote a multi-volume set called Principles of Geology. He is the direct influencer of Charles Darwin. Charles Darwin took Lyell's Principles of Geology, took the idea of uniformitarianism and applied it to biology. So uniformitarianism is not solely applied to geology, it's applied to everything as far as evolution is concerned. So Sir Charles Lyell is the most important proponent of uniformitarian or evolutionary geology. He is the one that promoted it and brought it into mainstream science just like Darwin did. So Darwin and Lyell are parallel, though Lyell predates and Lyell influenced Darwin. So now we are going to start comparing the two paradigms or the two presuppositions. Catastrophism is a presupposition of a creationist paradigm. Uniformitarianism is the presupposition of evolutionary geology. Okay, they're all presuppositions of those two, they're both presuppositions of those two paradigms. Catastrophism. I'm also going to use the word belief here as well because it is a presupposition. It's something that I assume to be true. And this is how I interpret geology, is through catastrophism. Just like evolutionists interpret geology through uniformitarianism, I'm going to interpret geology through catastrophism. Catastrophism is a belief. It is a presupposition that I use to interpret geology, just like evolutionists use uniformitarianism to interpret geology in their paradigm. So catastrophism is the belief that the geological features of the earth are more readily explained by catastrophic events, especially the Genesis flood, as described in Genesis 7 through 9. Okay? So this is my presupposition. This is the presupposition that we use as creationists to interpret geology. And we are interpreting. Remember, geology is, this type of geology is historical science. So we're just as limited as evolutionists are. But the idea for this class is for me to show you what I've said here, more readily explained. We're going to show that catastrophism, both catastrophism and uniformitarianism, are presuppositions that we interpret our data with. But we're going to show that catastrophism is better than uniformitarianism at explaining the Earth's geological features. Okay, so with catastrophism, here's our main points with catastrophism. Catastrophism teaches that natural processes are insufficient to explain observable geological features of the Earth. Natural processes acting over time. Remember, what's uniformitarianism? It's natural processes over geological time, over millions and millions of years. And we're saying that they are insufficient to explain the observable geological features of the Earth today. Here are some things that uniformitarianism has trouble with, and we're going to talk about this in a little bit of detail. Transcontinental sediment layers. How did that much uniform sediment get laid down? Meaning it was laid down all at once. Natural processes over geologic time, or the universal flood. Plate tectonics uplifted the Colorado Plateau. We're going to be talking about the Colorado Plateau. What's in the Colorado Plateau? Who knows? How many of you have been out west? What's in the Colorado Plateau? Everybody goes there and climbs. Goes in and out. Probably shouldn't do it in one day. You should probably spend the night. What am I talking about? What's in the Colorado Plateau? Absolutely, the Grand Canyon. Grand Canyon is a little bit of a problem. I guess not a little bit. It's quite large. Did you know that you cannot see the entire Grand Canyon even from the air? You'd have to go into orbit and be on the International Space Station to be able to see the Grand Canyon in its entirety. Or in the space shuttle, but I guess we don't have, NASA's kind of abandoned that program. And of course, here's the biggest problem. The Colorado River carved the Grand Canyon. That's the only uniformitarian explanation. Natural processes over geologic time. That's uniformitarianism. Natural processes over millions and millions of years. In other words, the present is the key to the past. We look only at present processes that we can observe and measure now and use them only to explain the Grand Canyon or to explain transcontinental sediment layers or to explain some of the cliffs of Dover and things that are seen in the UK. Okay, there's the Grand Canyon. I have not been there. I need to correct that. But anyway, here are some features of the Grand Canyon. 277 miles long. Remember, you have to go to orbit to see it in its entirety at one time. More than 18 miles from rim to rim at its widest point. 18 miles across at the widest point. On average, it's about 10 miles wide, because there are some places where it's not nearly 18 miles, but on average, it's about 10 miles wide, 18 miles from rim to rim at its widest point. 1 mile deep. I saw one person who tried to put this in perspective using New York City. And 277 miles is longer than the island of Manhattan, which of course is the main island of New York City. It's longer than the island of Manhattan. Much, much longer. In fact, 18 miles. 18 miles is the length of the Manhattan Island, which is, of course, the main part of New York City. So you could take Manhattan Island and put it lengthwise on one rim and barely touch the other rim at that 18-mile point. A mile deep. The Empire State Building, you'd have to stack 4 of them, okay, to be about a mile. Okay, then, of course, the Grand Canyon National Park. It'll be celebrating its 100 years in 2019. It was established in February of 1919. That was, of course, 3 years after the National Park Service was established. And the park is approximately 1,900 square miles, which is over 1.2 million acres. So quite a geological feature. Quite a problem for natural processes over geologic time to explain. So we're going to use this as an illustration. I want to illustrate the fact that catastrophism is a much better explanation for the Grand Canyon. Formation. I got this from the National Park Service. How did the Grand Canyon form? How can we explain its formation using natural processes over geologic time? This is a quote on how the National Park Service explains the formation of the Grand Canyon. It's kind of interesting. This is the wording. The story begins. At least they're being a little honest there. The story, remember, once upon a time. So once upon a time, well, the story begins almost 2 billion years ago with the formation of the igneous and metamorphic rocks of the inner gorge. That is the bedrock, which of course would be the lithosphere. Okay, igneous, metamorphic, and sedimentary are the 3 kinds of rocks. You probably remember that from grade school, junior high or something. Igneous, metamorphic, and sedimentary. Of course, the bedrock of the Earth's crust is made of igneous and metamorphic rock. The 2 basic kinds of rocks are igneous and sedimentary. Metamorphic is rock that has been altered by heat and pressure. So igneous rock is formed by the cooling of molten rock. Metamorphic is rock that's been altered. Sedimentary rock is rock that has been laid down by water. Okay, so 3 types of rocks. Igneous and sedimentary. Both are formed completely differently. By the way, only igneous rock can be even attempted to be dated radiometrically. Sedimentary rock cannot be dated, not by radiometric methods. stated by the fossils that contains. Okay, and then metamorphic is when either igneous rock or sedimentary has been altered by heat and pressure. So the story of the Grand Canyon, or the story of this particular feature of the Earth, begins 2 billion years ago. Gotta have lots of time. Then layer upon layer of sedimentary rock was laid upon these basement rocks. The basement rocks are igneous. The very top layer of the Grand Canyon is limestone. Very interesting. Do you know anything about limestone and its origins and how it forms? It's very high in calcium carbonate. And this is sedimentary rock that is laid down in oceans and seas. It's a sedimentary rock. So the top layer of the Grand Canyon was laid down with limestone, not sandstone. Next, got a lot of time between 2 billion and 70 million. 70 to 30 million years ago, through the action of plate tectonics, the whole region was uplifted. And that's what we call the Colorado Plateau. The Colorado Plateau is anywhere from 6,000 to 13,000 feet above sea level. Talk about uplifting. The uplifting would have to have been at least 9,000 feet. So between 70 and 30 million years ago, through the action of plate tectonics, the whole region was uplifted. Finally, beginning just 5 to 6 million years ago, the Colorado River began to carve its way downward. Okay, again, I got that from the U.S. National Park Service. Their explanation of the formation of the Grand Canyon. What is it? It's natural processes over geologic time. Basically, of course, the bedrock was 2 billion years ago. So then if we get down here, the Grand Canyon itself is only 5 to 6 million years old. That's when the Colorado River carved out the plateau. There's some big problems here. The Grand Canyon raises many questions that are a problem for uniformitarianism. That's why I'm going to try to show you that catastrophism works much better than uniformitarianism. How were so many layers of sediment laid down in so large an area? Natural processes over geologic time, or what's the alternative? The flood. How did the seafloor rocks, there's the top layer of limestone, how did they obtain such high elevations, anywhere from 6,000 to 13,000 feet above sea level? On average, 9,000 feet above sea level. How did that happen? And then another problem. These layers are nearly horizontal. Any uplifting that we see from plate tectonics is always deformed. So how was the Colorado Plateau uplifted 9,000 feet without the deformity of the rocks? If you look at other uplifted areas like the Rocky Mountains, those rocks have been drastically deformed. So if plate tectonics formed the Rocky Mountains, then of course we would see the deformed rock, and we do. But how can we then use the same mechanism to explain the Colorado Plateau? It's a problem. I have a better explanation. What's the mechanism? Do plate tectonics do that? Can they do that? How does a river like the Colorado carve such a vast gorge, 277 miles long, in places 18 miles across and 1 mile deep? What's the source of the flooding necessary for downcutting? Downcutting is the mechanism proposed to account for the carving of the Grand Canyon. Lots of questions. Here's the Colorado River. I guess it took 5 million years for it to carve this out, but where was the volume of water? We've got to have vast, vast, vast amounts of water. Is the runoff from the melting snow enough? I don't think so, even if we give it 5 million years. A lot of questions. Here's the alternate view. I'm not going to take the time to read it. In the 600th year of Noah's life, rain upon the earth 40 days and 40 nights. This is Genesis 7, excerpts out of Genesis 7 and 8. Waters prevailed exceedingly upon the earth, and all the high hills that were under the whole heaven were covered. 15 cubits upward did the waters prevail. Is this how we got all that down cutting? Sounds like a better explanation to me. The waters prevailed upon the earth 150 days. And then the waters returned from off the earth continually, and after the end of the 150 days, the waters were abated. And the waters decreased continually until the 10th month. And it came to pass in the 601st year of Noah's life, is what that's talking about. In the first month, on the first day of the month, the waters were dried up from off the face of the earth. What is that? Look at the wording, prevailed exceedingly. Okay, Genesis 7 and 8. So, here's our alternatives. We've got the flood, and then we have the Colorado River. Okay, what's the better mechanism? Here's the last thing. Here is Henry Morris's best contribution. Prediction versus accommodation. The flood would predict the Grand Canyon. Evolutionary geology has to try to explain it somehow. Do you see the difference? Prediction versus accommodation. The flood would predict things like the Grand Canyon. Uniformitarianism has to try to explain it. That's accommodation. So the Genesis flood, we're going to spend a whole lecture on this. Don't try to write it. This will be a whole lecture. It's showing you this. But the Genesis flood is a much better explanation for the Grand Canyon and other specific Earth features. It's the best explanation for what's actually in the fossil record. It's the best explanation for the sedimentation that we see. It's the best explanation for the breaking up of the continents, okay? It's the much better explanation. There's also neocatastrophism, which is a compromised position because guess what? Uniformity's having trouble explaining things, so it's going to adapt or accommodate. Okay? Prediction versus accommodation. There's Henry Morris. And William Buckland is another catastrophist, though he was not a creationist. The Genesis flood, Whitcomb and Morris. Dr. Morris is a engineer, hydrologic engineer. Whitcomb is a theologian, published in 1961, and this was really the start of the modern creation science movement. All right, so we will have to stop there, but I want you to see that the which model is the best.